All right, let's see if this makes sense to you. Okay, the whole goal of selecting an alkyl halide for an SN2, the smaller, the better, basically. All right, if the environment around electrophilic center is wide open, not a lot going on around the electrophilic center, that's a good substrate for an SN2 reaction. All right. Let's take a look in the first set. We have A, B, C, and D. Which ones go SN2 the fastest one? Let's say all of them have the same electrophilic center, which is carbon next to bromine. The nucleophile will attack at that position. All right. The worst one, I'm sure you see this. The worst one is C for sure. Too many things around electrophilic center. All right. So if the a nucleophile were to approach this carbon, they have to go through pass through electron density of this 4 methyl group, and it's not really I mean it's possible, but it's just really difficult, right? So C gonna go with the slowest rate. D, the environment around this electrophilic center is wide open, just two hydrogen there. So 4 hydrogen. This is 4 methyl group is too big, too bulky there. This guy is wide open. So D should be the fastest one. C should be the slowest one. All right. Now A and B, you should be able to guess as A. This 2 methyl group is closer to the electrophilic center, so it will somewhat block an SN2 reaction. But this 2 methyl group is wide open. It's like further away. All right. So B maybe the environment around electrophilic center is still wide open, right? So maybe the rate of B maybe really close to D if it's not equal. Okay, so I'm gonna go D, the fastest one, right there. Go followed by B, followed by A, and followed by C, the slowest one. Okay. All right, down here. So I add a stereochemistry in the molecule. So don't feel don't get nervous or freak out or anything. Try to look at one thing at a time. What could happen? What could not happen? All right. Now, in A through E in set number 2, there are 2 molecules that completely block backside attack. You know which one? Completely block backside attack. Never happened. Yeah. So we have an A for sure, tertiary alkyl halide. If you can see that, right? So carbon connected to 3 carbon. Carbon connected to 3 more carbon, so we call tertiary alkyl halide. So never do SN2. So A is no. D also a vinyl halide, right? Vinyl halide or chlorine, bromine, iodine, halogen on double bond. Never ever do an SN2. Too high electron density on the pi bond right here, right? So A and D, no SN2 reaction. Okay. All right. Now compared to E, C, and B, analyze the structure. Who goes the fastest, E, C, or B? E first for sure. So the environment around this electrophilic center is wide open. See that? So E should go the fastest. C and B should be really close there. I mean, slower than E. All right. So I'm gonna go. Hold on. Let's go wide open. Good. Okay. All right. So C and B. Who's faster? Well, think about this though. We're about to do SN2, which is a backside attack. All right. So the nucleophile have to approach this chlorine from the opposite direction. Both chlorine point up towards you. So the nucleophile have to go away from behind the molecule. All right. So if hydroxide ion so a nucleophile come from behind, do any of this methyl group affect that nucleophile at all? Yes, actually, yes. These 2 methyl group point up towards you, which means it's point away from the direction of the nucleophile. These 2 methyl group, on the other hand, point away from you, which is point to the direction that the nucleophile coming in, right? So C gonna block the backside attack a little bit more than B, right? Slow down the backside attack right there because it's point to the same direction that nucleophile coming in. This for B, nucleophile comes in from the back, but this methyl group point to the front, doesn't do anything with the nucleophile. Maybe do a little, right? So C should be slower than B. All right, I'm gonna put a trend right here. So I'm gonna go E, the fastest one, B and A and D like the worst one for sure. So E, go to B, go to C, and then A and D. Whatever, I don't know. I mean, they don't do reactions, so we can't really tell who's faster. Okay. All right, that's how you think about it. So the more practice, the more you be familiar with this, like how to determine or how to select the reagent. All right, we're gonna use that at the end of this chapter. This guy will come back. Okay. All right, next one.